Welcome to the lecture on joint plots. In this lecture, we'll look at data visualization using joint plots. Let's start by importing the libraries and modules that we need. I copied this from the previous lecture. Import NumPy as NP, Pandas as PD, Seaborn as SNS, Matplotlib's PyPlot as PLT, and Matplotlib inline, which is a special Jupyter function that allows us to see our plots on Jupyter Notebook. So Seaborn has a number of data sets that we can use for our learning purpose. What we'll do is we'll use two of the data sets that Seaborn has. One is called the tips dataset, the other one is called the iris dataset. Let's first import these datasets and show you. So SNS that there is a method called load dataset that will help us import these datasets. So SNS.load dataset and then pass the name of the dataset. So the first one is tips, and let's save this in a variable called tips. So if we see the tips dataset, tips.head, we see that we have the following columns: total bill, tip, sex, smoker, day, time, and size. This is based on people who dined in a restaurant and how much they paid, how much tip they left, whether it's a female or a male, smoker, day, time, and then family size. The second dataset that we'll use is called the iris dataset. So SNS.load dataset, load underscore dataset. Then name of our dataset is iris. Let's save this in a variable called iris. So let's call iris.head. This dataset is on the iris plant, and this iris has three different species named Setosa, Virginica, and Versicolor. And this dataset describes the sepal lengths, sepal widths, petal lengths, and petal widths for those three species. Now let's start by visualizing this tips dataset by using a joint plot. What we'll do is we'll take this total bill and the tip column and visualize it by using a joint plot. So we'll use the total bill as our x variable and then tip as our y variable, and use joint plot to see the relationship between those two variables. Let's do that. So to do that, we simply start by saying SNS, and then from Seaborn we'll call the function known as joint plot. So SNS.joint plot, and then we pass our x and y variables. So our x variable in this case will be total bill, right? Which is here, total underscore bill, and our y variable will be tip. So let's pass that too. Our y variable is tip, and the joint plot method also takes another function, another attribute known as data. So for this, since we are using the tips dataset, we'll pass that. We saved it in a variable called tips, right? So let's pass that. Data is tips. Okay, now if we run this, we see a joint plot of the tips dataset. We have total bill on the x-axis and we have tip on the y-axis. So here we have a scatter plot to show the relationship between those two variables, total bill and tip, and we have marginal distribution of each variable on a separate axis, right? Here and here. Let's look at one more example of the joint plot, but this time let's use the iris dataset. So what we can do is sns.jointplot. We call the joint plot function, and it takes the x variable, which we can use. Let's see the relationship between sepal lengths and sepal widths for the iris dataset. So let's do that. Let's have our sepal lengths as our x-axis. For our y-axis, we can use, let's say, sepal widths. And we say that joint plot also takes another attribute known as data, and we'll use the iris dataset. So if we run this, we get this nice joint plot. So on the x-axis we have sepal lengths, on the y-axis we have sepal widths. This shows us the relationship between those two variables for the iris dataset, and we have a marginal distribution of each variable on our separate axis. So in these two examples, we have scatter plots and then histograms on the margin. What we can do is we can also add some regression lines for our scatter plots and a kernel density fit for our histograms. To do that, we'll pass another attribute in our joint plot method, which is called the kind attribute. Let's do that. So we have sns.jointplot, and then we said that for our x-axis we'll use total bill. For our y-axis we have tips, and then our data comes from the tips dataset, and we'll pass another parameter or attribute known as kind, and we'll set that to be equal to reg for regression. Now let's run it. Oh, I know what our error is. So our y-axis is tip, not tips. Let's run it again. Okay, here now we have total bill versus tip, and we have a regression line for our scatter plot and a kernel density fit for the histogram. Great. If we want, we can also change the color of our joint plot by passing the color attribute. So for instance, we can say color is equal to, let's say, green. So now our joint plot is green, so you can do that.